Generate equivalent exponential expressions. So number one says rewrite the following expressions as a single power base. So we have rewrite 8 to the power of 1/4 times 2 to the power of 2/3 as a single power of 2. So this second part, this 2 to the 2/3, that is already a power of 2, right? It already has a base of 2, but the problem is the 8 isn't. We want to rewrite this as a single power of 2. Now 8 is not to the isn't the base of 2. So we need to change that. So the thing is, what can we write? How can we rewrite 8 to have a base of 2? Well, isn't 8 just 2 to the power of 3, right? Because 2 times 2 times 2 is 8. So I'm going to rewrite 8 as 2 to the power of 3. And of course, that's to the 1/4, and then 2 to the 2/3. So now I've rewritten as 2 to the power of 3. Now by our exponent rules, what I can do now to simplify this is do the 3 times the 1/4, right? That's what our exponent rules tell us. 3 times 1/4 is 3/4. And then our exponent rule here tells us to add the exponents. So we're going to do 3/4 times 2/3. Now I'm just going to use a calculator for that. 3/4 plus 2/3. I got 17/12. So again, 3/4 plus 2/3, that would be 17/12. So I'm going to have 2 to the 17/12. Okay, so let me show you another one. Okay. B says rewrite that expression as a single power of 7. So that 7 to the 3/2 is good. That's good. But the 49 isn't. This 49, we need to rewrite that as a power of 7. Well, isn't 49 just 7 to the second power? So we're going to rewrite this as 7 to the second power to the 2/5. Rewrite that. So all I did was change that 49 to 7 to the second. Our exponent rules tell us we can multiply those. So that's going to be 7 to the 4/5. I still have 7 to the 3/2. And again, our exponent rule, if we have the same base, we're going to add those exponents. So 3/2 plus 4/5. Just using my calculator here, converting it to an improper fraction. I got 23 over 10. Let me show you a couple more. We want to rewrite this as a single power of 5. So 25 we got to work with here. 25, isn't 25 just 5 to the second power? Yeah. It's going to be 5 to the second power, 3/4. I still have my 5 to the negative 1/3. So again, I'm going to multiply here. 2 times 3/4 is 3/2. And then we add the exponents. So 3/2 plus 1/3 or negative 1/3 be 7/6 is what I got. So this is going to be 5 to the power of 7/6. Show you D. Single power of 3 we want. So this one's interesting because neither of these are a power of 3 right now. But I can make them one. 9 is just 3 to the second power, right? And 27, is 3 to the third power. 3 times 3 times 3 is 27. So I'm going to multiply that. That would be 5/2. that would be 3 halves. And then we add, right? Same basis. So we're going to add 5 halves plus 3 halves. I can do that in my head is 8 halves. And then 8 divided by 2 is 4. So this is just 3 to the 4th. And if you're not too good with fractions, use your calculator. Okay. I'm going to let you do the rest here for E, F, G, and H. Just remember, you can change this 0.5. Don't let this confuse you down here. Just 0.5 is just a half. Just make it a half. Okay. Use the properties of exponents to rewrite the following exponential expressions in the form of a times b to the power of x. So we're looking for kind of this form here. So we kind of have to use backwards exponents rules. So 5 to the power of 3x, remember we just have a 3 times x up there. So what we could do is rewrite it like this. That's equivalent because 3 times x is just 3x. I've kind of reversed the exponent rule. I've kind of broken it up. And then 5 to the third is 5 times 5 times 5, which is 125. So 125 to the power of x. Now, technically, this is in this form. So I should kind of put it like that. Technically, it is in this form. We just don't have an a value. If you're asking for an a value, it would just be like a 1 here. But you don't need to write that. Erase that. So with C, let me do C. I'm going to break this up. So we have an 2 to the power of x minus 3. So how we can break this up is 2x to negative 3. Because if I were to now to combine this, right, wouldn't I do x plus negative 3, which is the same as x minus 3? So this is an equivalent step. Now I can evaluate this 2 to the negative 3. I could use my exponent rules to write it as a fraction, but I'm just going to use the calculator and get the decimal. 2 to the power of negative 3 is 0.125. And I'm going to put this in front because I am trying to write it in this sort of form where that a value is just a number. So 2 to the negative 3 is 0.125. And then I'm just going to rewrite times 2 to the power of x. And you could also write it. Let me erase that really quick so I have more room. You could also write it so 0.125 as a fraction. If you convert that to a fraction, it's just 1/8. So you could write 1/8 2 to the power of x. Either of those are acceptable. Let me show you F. So hopefully you can try B and D. I know these are really weird and really goofy. Let me show you F. So what we can do here is we can make this 2 to the power of negative 3x and then times a 2 to the 4. Right? Because if we were to combine that, we do negative 3x plus 4, right? So I've just kind of broken it up. Next, I can even break up this one even more into 2 to the negative 3 to the x, right? Because I would just do negative 3 times x if I were to go back up with exponent rules. I'm going to rewrite this as 2 to the 4th. Now let me evaluate 2 to the 4th because that's just our number piece. That's going to be our a value in that form that was listed up there. So 2 to the 4th power is 16. So I'm gonna put that first. Then 2 to the negative 3 is 0.125. And then to the power of x. So just to not be confused on that last step, remember I'm trying to write it in this form up here. So I basically just put the 2 to the 4th here, and that's here. Okay. And remember, you can always kind of keep this as a 0.125. You can change it to a 1/8 as well if you want to make it a fraction, which is fine too. But I'm gonna leave the decimal. Okay. Show you another one. So I'm gonna have 1.25 to the power of 2x times 1.25 to the power of -3. Then I can break up this 1.252 to the power of x. Rewrite that. Now I'm going to do that 1.25 to the -3 first because that's going to be my number out in front, kind of my coefficient, if you will. 1.25 to the power of -3. I got 0.512. 1.25 squared is 1.5625 to the power of x. Again, like I when I evaluated this, I put that here. I hope you can make that connection. Let me show you one more here. So here I can break up 3 to the 2nd times 3 to the 4x. And then I can even do 3 to the 4 to the power of x with that term. Now, the nice thing with this one is I don't really need any switching around because that 3 to the 2nd is just a number, right? It's just 9. So that's gonna be right here, 9. And then 3 to the 4th is 81. And it's in the form. Okay. So I'll let you try to rest. I know that's really goofy there, but you do your best, okay?